Hello friends, welcome to the channel Physics by IITians. Today we continue our laser lecture number 3. So last time I told you that the lasing action will be only possible whenever there is stimulated emission. So the stimulated emission, whenever you, in case of two level system, suppose this is E1 and this is E2, okay. So whenever there is light incident with the frequency h nu, where h nu is the energy differences between the two levels, if there is an atom which is already in the excited state, and if this photon is in phase with this atom, excited atom, it can stimulate or force the atom to come down to the ground state, and then it will also emit some radiation which is h nu. So we will get 2 h nu. From one photon we can get 2 photon. So similarly there are a number of levels. So there are also populations in the excited state. This 2 photon also can excite further 2 atoms, and it will can come up to the ground state, and it will also emit photons. That is whether from 1 we get 2, from 2 we get 4, and similarly and for these 4 photons will excite. So from 1 h nu we can get 2 h nu, 2 photons. So from 2 h nu, if it can excite also further atoms, and it will we can get 4 photons. So the photons, similarly the number of photons will be amplified. Okay. So this is called the stimulated emission, which can cause amplification of the light. So this is the basic principle behind laser. And what I have told, that for laser we need 3 things. First, this is the active medium that is capable of the population inversion. That is, in all the cases we need more population at the excited level than the ground state level. So the active medium should be capable of population inversion. That is, what are the kind of active medium? Like helium neon laser, neon is the active medium. ND-arc laser, also ruby laser, ruby crystal is the active medium. So it will depend on the types of the laser. Not all the medium is capable of population inversion. So for population inversion, that is N2 is greater than N1. Suppose this is the level where the population is N2, and this is the level where the population is N1. So for making N2 greater than N1, we need some pumping, that is which we are doing. We are generating external energy. We are giving external energy to excite the atoms which are in ground state, to send it to the excited state. So this pumping may be optical pumping, may be discharge electrical signal, may be resonant transfer of energy. So the pumping scale will be different for different types of laser. And also we need a resonator. Why we need a resonator? Because we need the oscillation. That is, last time I also told you, suppose you have simply analogy, you have an analogy with the simple harmonic oscillator like pendulum, okay. So it is oscillating with certain frequency. If the length of the pendulum is L, then L should be 1 by 2 pi into root over of G by L. So now, whenever this is oscillating, now naturally it has some damping due to its losses. The amplitude of the oscillation will decay like this. After certain time, it will damp out and it will constitute no oscillation. So there will be exponentially decaying of the oscillation. But if we somehow put a person that you push the pendulum continuously or periodically, so that the oscillation is never dies out, so that the oscillation is continuing. So if we invest some kind of agent which is continue, which is doing making it capable of continuous oscillation, we will get the amplitude of oscillation like this, which is, there is no loss. I mean, it is continuously oscillating. So in this case also, the laser thinks that you have that active medium. Suppose this is the active medium, you are putting the pumping, so it is producing photons in terms of stimulated emission. Now you need someone, or you need something positive feedback which is growing with time, and you can get continuous output. How is it that? Suppose you are putting 2 mirrors, and suppose the mirrors have 100% reflectivity. Okay, the R1, R2 is 100%. This is also 100%. This is also 100%. So the laser light or light and radiation which is produced, it is going there. It is reflecting, coming back. It is going there. It is reflecting back. So it will be like it will continuously do a round trip. Okay. If now this reflectivity is 98%. So you have some radiation which is going outside the mirror, and that is the laser output. This is the basic scheme of laser, and the mirror is going to be, this is the resonator. Okay. So for laser we need three things. One is active medium, another is pumping to get population inversion, and last thing is the resonator. Okay, so one certain trip, round trip, it can excite some other atoms to get excited and to do stimulated emission. For another round trip, so the population, due to the round trip, the population inversion will be higher and higher, the stimulated emission will be higher and higher, and you get laser signal easily. Okay, now what is the scheme, how do you think that what are the minimum mediums or metals that can be active medium? Okay, so active medium, we can think that there are certain energy levels inside any material which can be act as an active medium. Which kind of medium or material or levels which will act as active medium? Suppose there are only two levels which I have earlier discussed. This is called two-level system. These are the discussion for the active mediums. Okay, suppose there are only two levels, that is two-level system. One is A1, another is A2. Now Einstein AB coefficient, last time I told you that there will be the absorption due to the emission of radiation or incident radiation to an active medium, to an active medium. This is the emission absorption process. There can be spontaneous emission, because whenever atom is going a higher state, it cannot stay there for infinite time. It has certain lifetime, so it will come back after a certain time to be stable. So it is spontaneous emission, and whenever there is another photon which can excite this atom and the atom will come back to the ground state, it is stimulated emission. So there are three kinds of processes. It's the light matter interaction: absorption, spontaneous emission, stimulated emission. Now if we can write in terms of equation, so we can, the rate of change of N2, that is the population at level 2, is equals to B12 N1 U minus A21 N2 minus B21 N2 U. So B into, so whenever in terms of Einstein coefficients, if you write that the B12, A21, B21 as B or A, so you will get this final equation dN2 by dt equals to B into N minus 2N2 U minus A N2 equals to 0. Okay, because suppose this total number of atoms N1 plus N2 is N. You put the values and you do the calculation, that you will get the excited population at the excited state, that is N2 will be BUN by A plus 2BU. So you take the ratio of N2 by N. Okay, if you take the ratio N2 by N, for population inversion, the minimum criteria is N2 is greater than N2 by N1, the ratio should be greater than 1, or you can tell us N2 by N1 should be greater than 1, that is N2 is greater than N1. Okay, now if you take in terms of two-level system, you can never achieve this condition, because wherever in the two-level system the maximum condition is achieved that N1 is exactly equals to N2, that if there are 4 atoms, there also will be 4 atoms, that is N1, N2 by N1 you will get, that is 1, and this kind of situation is called saturation, and you can never achieve beyond saturation. I mean, in two-level system you can't achieve the population inversion to do laser. So two-level system, basically it is a not good for a laser system. Now we should cross it out. Now we should think further system so that we can get population inversion. The further systems are like 3-level system, 4-level system. What are the system? Those systems like 3-level system. We have 3 levels. That is, suppose this is E1, this is E2, and in between them there is another state which is E3, which has larger lifetime than E2. So suppose this has a lifetime tau 2, this has a lifetime tau 3. Now suppose tau 3 has much greater than tau 2. The lifetime of tau 3 is greater than tau 2. What will happen? The lifetime, I mean the atoms can stay here for much more time compared to this atom staying at this level. So whenever you excite atom in terms of any pumping scheme, the atom will get excited and it will go higher state like E2, and now it can non-radiatively decay to the another level, that is E3. Okay, so this is non-radiative decay, means you don't get any radiation. What do you mean by non-radiative decay? The decay means that it will excite thermally. It will excite the atom or material thermally, but it will not produce any radiation. So you are exciting this atom to this level, and it somehow then after certain time, which will depend its lifetime, it will come back to this level and it will non-radiatively come. It will not cause any radiation. So it will come and stay here for a larger time. Meanwhile, the excitation is also happening, pumping is also happening. So more atoms will be populated to this level, and it will come back non-radiatively, and the atoms can stay here much more time. So you will achieve some population inversion compared to this ground state. So finally, whenever they come back to the ground state, you can have laser. This is the main scheme of 3-level laser. That somehow you in between the 2 levels there are some other levels and it has some larger lifetime. So the atoms which are pumping which can go this state, that is excited state, it can come back to the state in non-radiatively, and then it will decay, and then it will come back to this ground state, and it will further cause radiative transition, that is the laser you can get. This is the non-radiative and this one is the radiative. Now this is a scheme, that is the 3-level system, and there are another kind of materials that is consisting of 4-level system. What is that? Suppose in between the 2 levels, that is E1 and E2, there are other 2 levels, that is E3 and E4. Now the lifetime is tau 2, tau 3, tau 4. So if tau 3 is greater than tau 2, okay, so now what will happen, that this atom you will excite it and it can go to this level, and now after certain time it will come back by non-radiative decay to the level E3. So similarly the happen with all the other atoms. So it will come back to level E3, tau 3. Now to level E3. Now it can radiatively decay to tau 4, and this tau 4 to, suppose this is tau 1, it can continuously, I mean the lifetime between tau 3 tau 4 or is the radiative decay. In this level there is the radiative decay, but these 2 levels, this is the non-radiative decay, and in between also these 2 levels, this is also non-radiative decay. Suppose I denote non-radiative decay like this notation. So this transition is non-radiative, this transition is non-radiative, and these 2 transitions are faster. These are the faster transition. This is also a faster transition, and this is the radiative. So this kind of scheme is, that is 4-level system. Somehow the atom get excited to level E2 and then it come to level E3 non-radiatively, then it gives the radiative transition, then it come to ground state or E1 level non-radiatively. Okay, so the laser action will be happening between these two levels, E3 and E4. Now to compare, the 3-level system is better or 4-level system is better. The 3-level system, you are missing this E4, so you are competing with the ground level and the E3 level. I mean the ground level population and the E3 level population will be compared for population inversion. So it is quite difficult to achieve population inversion in case of 3-level laser. But here the competition in between E4 and E3. So E4 is already empty. So you can easily, if whenever there is only one atom, it also population inversion for the E3 E4 level, because E3 is much more populated than E4. So in case of 4-level system, the population inversion is much easier, because you don't need to compete with the ground state level, and you all know that ground state level is always much more populated than the high state levels. So in case of 3-level system, you are competing with the ground state level, but in case of 4-level system, you are competing with the intermediate state, which is already empty, okay, or which may have some populations, but this population at the E3 level can be easily gated, and we can easily achieve population inversion. So 4-level system is much more better. So therefore we are talking about today the level system, the active medium, that is 2-level system, 3-level system, 4-level system. Next time we will see the laser output, after oscillator, passing through the oscillators, which kind of frequencies we can select, what will be the bandwidth of the output laser output. So we'll discuss more about laser. Hopefully you can understand today's lecture. If you like the lecture, please like our channel. Also we have some Telegram channel, Physics by IITians official, where you can easily put your queries, questions, and also we post our questions. Another channel, Physics by IITians, also on the Telegram. So today's I will also post some questions to the Telegram channel, and please do participate and learn physics actively. Thank you.